Hello and welcome to the session. So let's continue our discussion for remaining topics. So we'll talk about the other object-oriented programming topic called as coupling and cohesion. These are very simple topics to understand. So what is coupling? So the dependency of one class's functionality on another class for a desired task is called as coupling. So ideally, entire software functionality of your application could be done using a single class. Okay, so in your entire software application, it can be done using a single class, right? But that is a very bad design. Okay, which is not logically correct. So individual task or functionality is distributed among different or helper classes, and they are coupled with main class. So this is the correct way to divide and develop your software, uh, web application or any application. Now there are two things: one is tight coupling and one is loose coupling. So this is what tight coupling or a bad design, and loose coupling. So loose coupling is designed for the long term benefit. So let us see this with an example here. Now let us see, I have this file called as share trading app.java, and I have these two classes, Samsung Mobile and Micromax Mobile, and I have a manager which is going to launch that app on a particular mobile device. Now this is my share trading app. Now let us see what is happening here. So Samsung Mobile has a method called as launch app, and Micromax also has launch app method, right? Now I have this manager. What is happening here is I am creating an instance of both the classes here, and in the constructor I'm basically initializing it. And now in the method manage app launch, I'm launching app for Samsung or for Micromax and those devices. Now see what is happening here. So share trading app, and now here I'm just creating an object here. I'm passing those objects in the manager class constructor, and for the constructor I'm simply saying manage app launch. Now this is very simple and easy to understand. But now consider that this share trading app you want to launch on multiple Samsung mobiles, multiple types of handsets: Samsung Galaxy, Samsung A, and other devices. Micromax has hundreds of devices, hundreds of versions. Now, after Micromax, there can be another vendor for Android that may allow you to launch the app. Let's say Samsung, OnePlus 2, some Micromax, Asus, and multiple devices. Now, this is basically if you want to increase this, now expansion of this is basically will have lot of issues. What are the lot of issues? So first thing is that obviously you need to create extra classes, and your code here will keep on updating, will keep on changing. Now instead of one device, let's say there are 10 devices, and for some reason you want to remove one or two devices. So in that case, the design for this class will have to change frequently, which is not a good for a long term practice. For long term practice, we want that there should be very less changes in the implementation or in the classes, and we should be easily able to proceed without much changes. So now if you see here, this is that principle is violated here. So let us see an example where it is loosely coupled scenario. So I have this another class called as share trading app. Now here what is happening, let's take a look at this. So what I'm doing is I'm basically injecting an interface here, interface which will have to be implemented for multiple classes, multiple mobile devices who wants to use the app launcher functionality, right? So now if you see mobile Samsung, mobile Micromax, mobile Asus, mobile OnePlus 2, and many other classes, so they have to override it. They need to implement that interface, and they need to have their own uh, way of launching the app. Now this is kind of similar to earlier thing, but now if you see, now I've added one plus two here. Now if you see here in the manager class, I am not dealing with each and individual mobile device or mobile handset provider. What I'm doing is I'm basically using this interface here, and with the interface, the same thing, I'm assigning the interface, and I'm just calling the particular interface variable who has implemented that interface, and calling the app launch here. Now no matter how many devices you add, right? This implementation will not change. This will remain as it is. Only thing what you need to do is basically in your main class you need to have multiple calls. So this is fine, this is anyway going to happen. Why? Because your number of devices will keep on adding or removing. So this code will anyway will be repeated. But the point here is this particular class code where the coupling is happening, that code will remain as it is. That code will not be changed drastically. So this is basically an example of loosely coupled. So loosely coupled methodology or loosely coupled class design is always preferable for long-term benefit. Loosely coupling is designed for long-term benefit. Okay, now next topic is cohesion. So it is a measure of how the class functionality is designed meaningfully, relevant, or focused to solve a particular problem statement. We will also see with an example. Changing implementation or enhancing methods functionality should have minimal impact on other classes. High cohesion is designed for long-term benefit. So let us see with an example. Right, so let's consider that I have a class monthly sales revenue reporting. Here I have to do multiple things. For example, I need to collect data from Excel from database. I need to process some settlement, payment settlements, refunds, return items and all. Then also process the tags and some actual graphical reporting part. Now, if you see here, this is basically low cohesion. Low cohesion in the sense that there are multiple things to be done and that is done basically with the same class here. Now, the same class is doing multiple actions here. Okay, if you see, there are multiple methods in the same class, and with that only the reporting task is being achieved. Now this is problematic for long term. Why? Because if there is an issue uh, in any of the processing, uh, that may not be solved very easily. Or if there are multiple people who are working on, let's say some people are working on data handling, some people are working on the settlement, and some people are working on this reporting. So they have to refer to the same class, or they have to refer to the method. And if they want to change it, other people will be impacted because other people has to take the latest code most of the time. Now how to solve this is one of the solution is basically high cohesion. So let us see how this is addressed here. Now I have this monthly reporting class here. Now if you see here, what I have done is data processing related and processing related task I have put it in a separate class. So this is basically separation. Okay, so this is basically delegating the task to different individual entities, let them do their work, and once they are done I will just reuse it. So that is what is happening here. So if you see, data processing is basically about data from database from Excel. Transaction processing is about better payment settlement, refunds and return items. And in my main class what I'm doing is basically I'm creating an object of the data processing. I'm processing the data, then I'm processing the transactions, and now in the uh, actual reporting I'm just processing the tags, and I'm doing a graphical reporting. Of course there can be a common file where this or common entity where this will write its output, this will write its output, and I can refer that in the tax section or graphical section. For now it is just one system or println, but this is the preferred approach for a long term system design. For a long term application design, you need to distribute or um, reduce the chunk of work to different small entities so that it is distributed. So high cohesion is desired for long-term benefits. So here it will also reduce the implementation efforts in one class, but it can be done in multiple classes. This is all about cohesion. Okay, let's see one small thing, that is coding guideline. So since we will be proceeding for further topics, so we will have to understand some simple concept like naming convention. So package name in your entire project, it is advisable to use lower cases. For example, JavaX or org JUnit or java.lang. For that matter, if you see here in the entire project, whatever we have discussed, every class name, every package name always starts with a uh, small letter, or preferably you use a small letter always. Okay, class name or interface name, advised to be used in uppercase. Okay, for example, car, bank, or if you see this class name, it always starts with the capital letter. Okay, every class name starts with a capital letter. Now, method and field names, they are advised to be used in a camel case fashion. For example, you see first letter is small and second letter is high, second letter is capital, and so on. So this is basically a picture of camel case. So like, capital and small, capital and small, capital and small. So this is preferred. There are some projects which do not follow this, some project which follow this. So it is a common practice and advisable. Constants are basically final values, so it is advised to be used in uppercase. Okay, separated by underscore. For example, size or minimum underscore value or value underscore of underscore pi. So constants are let's say rate of interest. So capital rate underscore of underscore interest. So advisable to use in capital. Local variable advised to be used in camel case. Okay, so let's say employee name, birth date, email, and so on. So it should start with small letter and use a camel case. Let us see one more topic here called as um, upcasting and downcasting. So now you have a base class here and you have a derived class. So yeah, so this is basically an example of upcasting where left hand side, if you see, left hand side is the variable of the base class and right hand side you are assigning an object of the derived class. So base class equal to derived class. This is basically upcasting. So the variable of base class B is upcasted to the derived class. This is basically upcasting, and this is an example of downcasting where you are basically downgrading the child class to the base class. Okay, so this is basically D3 is downgraded to B2. Normally upcasting is only used, but for sake of understanding I have put this uh, downcasting example. Okay, so that's it for this particular session. Let's continue other topics in subsequent sessions. Thank you.